Let's learn about velocity and acceleration today. To begin with, we understand from class that velocity is how fast something is, which is a displacement over a time. Now, we write a little line above the v to represent it's a vector. We can write d over t, and since displacement is a vector which contains two parts, both the amount, which we call magnitude, as well as the direction, we could also say that velocity is a vector, thus the line over it, which has a magnitude and a direction. Direction can be positive, negative, left, right, that kind of stuff. So let's take a look at a multiple step or multiple path situation. Let's say we first have some path to the right. We go 800 meters. And let's say we do it in 20 seconds. We call that D1 and T1, our displacement in time. And then we go for 600 meters at a velocity of 10 meters per second. We know the time for them. Our goal is to figure out the overall velocity, otherwise known as sigma v. That's a Greek letter again, which means overall. So we need the overall, or sigma, displacement in time to help figure this out. So first we're going to find the total, or sigma displacement. We have two displacements there. We just add them up. We get 1400 to the right. Notice it's to the right because it's a vector. Then for the total time, we have to figure out the time for the second part. We know the first part is 20 seconds. So for the second part, we're going to use velocity as displacement over time. And we're going to say that the velocity of 10 equals the displacement of 600 over time t. Just to make sure I understand the math, I multiply both sides by t so it cancels out. I'm left with 10t equals 600. Divide both sides by 10, and I get 60 seconds. So the total time, or the sigma time, is 20 plus 60, which is 80 seconds. Now, to find the total velocity, or sigma velocity, displacement over time, I use the total displacement, which is 1400 meters, and 80 seconds of my total time. And I get 140 over 8 meters per second to the right. That's my vector. And you should reduce that to a mathematical number later on. So let's look at another situation where you go right 60 meters in 10 seconds, and then you suddenly turn backwards and go 4 meters per second for 3 seconds. Again, our goal is to find the magnitude or amount and the direction of both the net or sigma displacement and the net or sigma velocity. So first thing we're going to do is we're going to look at the total displacement. We know it's 60 right, and then we're going to use velocity displacement over time for the left-hand one. The velocity is 4, the time is 3. I get 12 meters to the left. So you subtract them because they're opposite ways, and I get 48 to the right meters. That's my total displacement. Now let's find the velocity. Velocity displacement over time. Total displacement is 48 meters. Total time is 13 seconds, and I get some value. Now I added both times together. You never subtract them because both times work together. I subtracted the displacements because they're opposite ways. So 48 over 13 meters per second to the right is the correct velocity. Let's talk about acceleration. Acceleration is how quickly you change speed, or how much the velocity changes by each second. So acceleration, which is change of velocity over time. Velocity involves a vector, so therefore acceleration involves a vector, which is why the lines are above it, and vectors, of course, have magnitude and direction. So it's really quickly how it changed speed. Let's look at this and see what it means mathematically without just doing equations. So if you run straight to a calculation, you're doing a bad thing, because it can actually kind of screw you up. So let's use logic. The first thing we're going to do is we're going to go 30 meters per second, and then we're going to put it into reverse with an acceleration of negative 3 meters per second squared. Again, that's in a unit, meters per second squared. So we're starting to go 30 meters per second at time is 0, which is the starting moment. And then each second, we're going to change by negative 3, which means we're now at 27 after 1 second. After 2 seconds, we lose another 3, or we change by negative 3, we're now at 24. After another second, eventually after 10 seconds, you can probably figure out, we'll be at 0. The entire time, from 0 to 10 seconds, we're slowing down because we're going from 30 to 0. Now, but if we keep going, for example, one more second, we've gained negative 3, we're now at negative 3. And another second after that, we gain another negative 3. So we went from 0 to negative 3 to negative 6. We're speeding up now. But we're speeding up backwards because it's negative. The entire time, the acceleration is negative 3 meters per second squared, or negative 3 meters per second squared. So what we're going to say is the velocity is changing by negative 3. I know you wrote negative 10, my bad. Negative 3 meters per second every second. It's not slowing down by that negative 3. It's changing by negative 3 because if you change by -3 and you're going backwards, it can mean your